In this video, I'm going over our first part of our interim review, which is focusing on the quadratics and exponents, but also the graphs of the quadratics. And the first few questions we are going over together as a group, but here focusing on this concept of the axis of symmetry. So here, remember, the axis of symmetry is basically our invisible line here that cuts our parabola in half. And if you think about it, right, that means it's going to go through the vertex, because the vertex is kind of like that midpoint, right, the turning point, where our graph stops increasing or decreasing and then switches the other direction. So like, for example, here, this is the axis of symmetry, right, because it's going through the vertex and it's cutting through. Now notice where our axis of symmetry is. It's in the negatives, right? So here it's actually going through at negative, it looks like -4 here. So -1, -2, -3, -4. So this is going through at -4. So that means so far we've got that negative value. So like here, for example, notice how this is cutting through. Well, this is at +1. It's cutting through at 1. So here we need the negative, right? Again, cutting this in half. This is going through at 0. X is equal to 0. We need negative. And then here, so notice how here we have cutting through at X is equal to -1. So far, the first and the last have that negative axis of symmetry. So now we're looking to see also now which has the positive y-intercept. So now notice here's our y-axis. Well, this graph is going to constantly keep going and eventually cross here somewhere below in the negative, but we need positive. So let's check the last one here. Here's our y-intercept right here at y is equal to 1, or at the point 0, 1. So this is that negative axis of symmetry, but a positive y-intercept. And so then here, our domain, remember the x values. So according to this situation, our domain is starting at the x value of 0 and stopping at 5. So here, again, according to this situation, so we could see this as 0 to 5, or we could also see this as 0 to 5. Now, the range is what's the y values. So like here, for example, some of us were mixing up the domain because you would say, oh, well, it's starting at 80. Well, no, notice how that's the y value here, you see? So that's those who are mixing up the domain and range. Now, the range, though, it starts at 80, right? Like that's our starting point for the graph. Like, let's say this is the height of, a balloon, right? It's starting at 80 feet above the ground, but technically it does go up, the highest point of 144 feet. So really, our range is not 0 to 80, but 0 starting at the bottom here to 144. And you could write that the same way. You could write it the same way here. You could have that 0 to 144, or you could have 0 to 144. So then the interval of increase. So again, this was something that people were mixing up as well. Well, the graph is increasing on this section up to our vertex, right, at 144. So our graph, and if you think about it, the axis of symmetry is what cuts this off, right? So at x is equal to 2, which means the interval of increase is just from 0 to 2. And then the decrease is this section, going from starting now at 2, but ending at 5. So notice how you have, again, using that axis of symmetry to help you with identifying that increase and decrease. So now here, the y-intercept. Well, what's the y-intercept? +5. So where it's crossing the y-axis, right? So here we're at 0, 5. Then the zeros are the roots. So remember, that's another way of asking for the x intercept. So we have how many? 2, right? -5 and 1. So x is equal to -5 and 1, or you could say -5, 0 and 1, 0. Remember the axis of symmetry, right? It cuts in half, going through our vertex. So notice how here it's cutting through. Now, so is our axis of symmetry positive or negative? It's negative, right? Right here, going through at -3. And then notice our vertex, which is a minimum, is here at -3, -4. So -3, -4. And so now here, this is just identifying, again, labeling all of our key information. So like, for example, here, you should notice that this was the y-intercept. Then here, where it's crossing the x-axis, what's our other word for the x-intercept? The 0 or the root. Then here up top, this point represents our maximum, which is the vertex. And then our dotted line here, that imaginary line that's going through, is our axis of symmetry, where we are cutting, that parabola in half. So here now, again, looking at this situation, we're talking about a swim team. And here, starting at this height, and then the distance from the springboard before, again, if this is talking about a diver, then here is our water here, right? So that's the water. So keep that in mind as you're going through these questions. So again, what's the domain? Remember, the domain is the x values, right? So remember, domain is the x. So don't start here at 14, right? That's on the y. So the domain is starting at 0 and going to 8. So this is 0 to 8, or 0 to 8. So then the range is now the y value. So now you're talking about that 14, but is this the highest y? No. Technically, here is the highest y value at about 23 feet. So it's from 0 up to 23. So 0 to 23, or 0 to 23. So then the interval of increase and decrease. So remember, right? Here is that axis of symmetry. So starting here at x is equal to 3. So I'll go ahead and add that in. X is equal to 3. So now notice, right? Remember, that's your splitting up the interval of increase and decrease. So we're increasing here. So from 0 to 3. But then we're decreasing starting at 3 and stopping at 8. So from 3 to 8 is your interval of decrease. So now what is the y-intercept? So where again is our diver starting at? 14, right? So 0, 14, that's where it's starting. Then the 0 or the root. Well, now notice we only have one right here, right? The x-intercept at 8, 0. Then the vertex, which we actually identified earlier as well, is at 3, 23. That's your maximum. So then here for question number 3, as we're going through and identifying to see which of these are all correct. You have a banana that's being launched from a slingshot into the air from a cliff. So here's starting from the cliff, and then here's our banana, right, going from a slingshot, and then boom, hits the ground. And this is the distance from the cannon or from the cliff. So now we're just identifying which statements are true. So is the y-intercept 0, 6? Yes. Is the vertex at 3, 12? No. Is the axis of symmetry at x is equal to 2.5? So notice here is the vertex, right? And is it cutting through at 2.5? Sure is. So C is true. The height of the banana is decreasing from 0 to 2.5. So from 0 to 2.5, what is the banana doing? It's increasing, not decreasing. So that is false. The banana reaches a maximum height of about 12.5 feet, so just above the 12. So yes, that is true. The banana is launched from a cannon 6 feet above the ground. Yes, that's what the y-intercept represents. The interval of increase is from 0 to 4. Well, we just discussed the increase is from 0 to 2.5. Because if you said from 0 to 4, 0, and then we stop here at 4. Notice this section, it started to decrease. So this is false. So now let's keep going. I'll go ahead and erase this information here. When the banana is 5 meters from the cannon, so when it's 5 meters from the cannon, it is 8 meters above the ground. So right here, is that true? No, because when it's 5 meters away, it's 6 above the ground, not 8. So then the domain is the domain from 0 to 6. 0 to 6. Yes, that statement was true. And so now you're not given the graphs and going back into Desmos and having to graph. Now this first one, you're given the equation, but it's just asking what does the 5 in the equation represent? What does this 5 here represent? So if you need the visual, then graph in Desmos, right? Don't worry about maybe wondering what this means. So here's the graph. Now zoom in, zoom out, do what you got to do, right? So now I notice that this is a very tall, very skinny, but when I go ahead and if I wanted to zoom in, I could see that my graph is crossing at 0, 5. That is the y-intercept, this 5 here. So what does that 5 represent? If it's the y-intercept, the starting height of the rocket. And so in the next one, we're actually comparing two situations. So you need to make sure to graph both of them. But in the end, what is the question? The question is asking by how many seconds does Rachel's textbook beat Amber's textbook to the ground? So when we were talking about the ground, if we ever had our graph here, right? And let's say it just kind of started like this. This was the start. We never focus on this because you can't travel in a negative distance or negative time. And then it would go boom, right here, right? Like hitting the ground. So really, what is this question asking for? The x-intercepts. So we just need to look to see how far apart are these two x-intercepts. So again, graphing in Desmos. So here's our graphs, right? Now you could zoom in, zoom out. You can see they're very tall, very skinny. However, in the end, what do we need? We just need to see not where here because we can't travel in the negative, but here, these two distances. So remember, these are the two x-intercepts we need to look at. So notice how this one's at about 4.5, so 4.5. And this one here is at about 5.1. So 5.1, this textbook landed 5.1 seconds. This textbook landed at 4.5 seconds. So we want to know how much sooner, right? So 5.5, whoops, sorry. So 5.5, here, let me erase that. 5.5 or 5.1 minus 4.5 seconds. So that means 0.6 seconds approximately is the amount of time that the textbook beat Amber's to the ground. So now this next question is asking for the appropriate domain. However, this one's a little tricky because notice answers are repeated. So we'll talk about that difference. So again, what is the appropriate domain? The x values. So now keep in mind, x is t. That is our time. So what is the appropriate domain? So again, graphing in Desmos. So now notice here's our graph, right? So we are going from 0 actually, which is nice. So 0 to 1.5. So 0 to 1.5. That is the x's. So that is the domain of this situation, the appropriate domain. So we can cross off B and D, because now we have to decide, is it A or is it C? Well, again, remember, what is the domain? Domain is time, T. That is your domain. That is the X. So that's why the answer is A, because what's the difference? This says T. That is your X. Whenever you have H of T, that is technically your Y. So this is your Y. This is your X. So that's why the answer here is A. And so for our last graph question here, again, focusing on the ball being thrown, here's the model with T representing your time in seconds, that's your X. So we're checking off to see all that apply. So the y-intercept is 0, 60, which shows that the ball is thrown from a height of 60 meters. So let's check to see. So again, the graph, now again, zooming out, right? And then we can identify those pieces. So here's our graph. Here we can identify those important sections. So here we go. Did our ball start at 60 meters? Yes, that is the y-intercept. So A is one of our answers. One x-intercept is at positive 20, which means the ball was thrown after 2 seconds. So let's check. Well, no, this is in the negative. And if you recall, we do not include because can you travel in negative time? No. So that statement is false. Let's check the next. 1x-intercept 0.6, and it shows the ball lands 6 seconds after it is thrown. So let's check and see. Right here, yep, it is starting at 60, going up, and then landing, boom, after 6 seconds in the air. So that is true. The vertex shows that the ball reaches its maximum height after 2 seconds. So let's see our vertex to see if that's true. Our vertex is here. Yep, it travels for 2 seconds to reach that maximum height of 80 feet. So that is true. The ball reaches a maximum height of 85. Well, nope, because we just stated that it reaches the maximum height of 80 feet. So that's why that last statement is false. And so now getting into the solving the quadratic equations, and then I'll remind you how you can also check your work in Desmos. So here, this is our special case, but now notice we can't take the square root yet because now notice this parentheses are being multiplied by 2. So we've got to get this by itself. So the opposite of multiplication is division, right? What we do to one side, do to the other side. So now I'm going to bring down x plus 2 squared is now equal to 4. Now, can we take the square root? Yes, take the square root. So canceling out, you've got x plus 2 is equal to plus and minus 2, right, from the square root of 4. So now you've got your two equations to set up. You've got x plus 2 is equal to 2, and x plus 2 is equal to negative 2. So now here, when we're solving for x, we're subtracting 2 from both sides of the equation. So we've got x is equal to 0, and we've got x is equal to negative 2 minus 2, which is negative 4. So we're saying that these are the two x-intercepts, 0 and negative 4. So if I were to graph this equation in Desmos, let's check and see, right? So again, you graph this in Desmos. Here's our graph here. I'm going to zoom back in so we can see, because all we need are the x-intercepts. So where is it crossing the x-axis? At 0 and negative 4. So notice how our answers match the graph. So again, remember, you can use Desmos to see where the x-intercepts are because that is the solution to the quadratic equation. So keeping in mind, here we go. We've got negative 5 times x squared. Well, again, don't add the 5, right? We need to do the opposite operation. So if this -5 is being multiplied, we need to do the opposite, which is divide by -5, right? So now x squared is equal to, that is +4. Now we can take the square root, and x is equal to plus and minus 2. So now here, there's different ways that you can solve this, but I'm going to go ahead and add 64 because this is a special case. Notice how we have no x term, right? So I'm going to go ahead and solve it like a two-step. 4x squared is equal to 64. Now we're still multiplying x by 4, so now divide, right? Opposite operation, divide by 4. X squared is now equal to 16. Now take the square root. So now here, when I take the square root, x is equal to plus and minus 4, square root of 16. So now for the next one here, this is again back to our special case, but we can't take the square root yet because it's not by itself. Notice how it's being multiplied by 3, and we're adding 7 to it. So first, remember, right, we always add or subtract first. So again, if we're adding 7 on the outside, subtract 7. So now we're going to bring down 3 times. X minus 4 squared is now equal to 27. Now we're still multiplying by 3, so the opposite, which is divide by 3. Now bring down. X minus 4 squared is equal to 9. Now can we take the square root? Yes, because the parentheses is by itself. So now canceling out, we've got x minus 4 is equal to plus and minus 3. Now we can set up our two equations. X minus 4 is equal to 3, and x minus 4 is equal to -3. So now when we go through and solve for x, we can add 4. And x is equal to, well, that's just 7. So same thing here, we're going to add 4, right? Opposite operation. And x is equal to, now that's -3 plus 4, which is 1. And again, of course, whatever answers we get, you can graph this in Desmos, and it should cross at 1 and 7. So now question number 12. Well, here now we've got a trinomial. We do have an x term here, so not a special case. Now I do notice though, because of the 2, do we have a GCF? No. So bottoms up, multiply. And we can start, right, because our equation was equal to 0. Now I've got x squared minus x, but now minus 20 is equal to 0. Now let's start our factoring. We're thinking of factors of 20, but -20. So because we're multiplying to get a negative, then the signs must be different. So factors to get to -20, and they're going to add to get -1, 5 and 4, but -5 and +4. But are we done? Do we change the signs and say our answer is A? No, because remember, with bottoms up, whatever we multiply by, now we need to bring it back and divide. So now simplifying, I've got x plus 2 from 4 over 2, and bottom up, 2x minus 5 is equal to 0. So now notice how x is equal to not +2, but -2 and +5 over 2. So that's why here the answer is C. Now in question 13, I'm going by my answer choices. See, with this complex, that means I know I'm going to use quadratic formula. But before we do that, here I'll write it out. So this was good old -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So now here, though, can we start identifying a, b, and c? No, because it needs to equal 0. So we need to first subtract 5. So now we're equal to 0. 3x squared minus 4x minus 5 is equal to 0. So now we can identify what's our A, what's our B, what's our C. So b squared -4 squared minus 4 times A, which is 3, times C, which is -5, right? Because remember, That's what's going inside of our radical here. We're focusing on this section. So now when you solve, you end up getting radical 76. However, radical 76 can be simplified. So radical 76, I can break this down into a perfect square factor of 4. 76 divided by 4 is 19. So now what is the square root of 4? Well, the square root of 4 is 2. So 2 radical 19. So we're going to set up negative b. Well, b is negative 4 plus or minus our radical, but now 2 radical 19 over 2 times a. Well, a is 3. Now notice we do have a 2 negatives making a positive situation. So this is now positive 4. I'm going to go ahead and cross out B and D because this is saying it stays negative. Now we're down to A or C. I can already tell from the radical and with the simplifying that my answer is going to be A. But just to keep going and show you, because this was radical 11. So here you've got 4 plus or minus from the positive 2 radical 19 over 6 from 2 times 3. So can we still technically simplify? Yes, because all 3 numbers are even, which means I can divide everything by 2. That's how you get 4 divided by 2, which is 2. 2 divided by 2, which is 1. And 6 divided by 2, which is 3. And so now with our last 2 quadratics here, now notice here, we are already equal to 0 and x squared here is by itself. We have that coefficient of 1. So we can go straight to factoring. And here, notice we have 2 positives, so 2 positives, right? What multiplies to get us 16 and adds to get us 10? 8 and 2. But remember, right, x is equal to negative 8 and negative 2. And again, if you were to graph this, your graph should cross at these 2 x-intercepts at negative 8 and negative 2. Now for 15, we have 5x squared. So do we have a GCF? Can I divide? No. So again, bottoms up. I've got x squared minus 38x plus 240 is equal to 0. And again, we could start the bottoms up because the quadratic was already equal to 0 here. Now we start our factoring. What numbers multiply to get 240? A positive. So that means the signs are the same, right? 2 positives or 2 negatives. And they're adding to get a negative 38. So that means they're both going to be negative. So add to get negative 38. So here you end up with 30 and 8. However, do we change the signs and say that's our answer? No. Remember with bottoms up, right? Whatever we multiply by that A value, now let's go ahead and divide. So now here we've got x minus 6 and 5x minus 8 is equal to 0. So notice how here we've got x is equal to positive 6, right? Because of changing the sign. So I'm already down to A or B. Then take the fraction. If the fraction was negative 8 over 5, now it's going to be positive 8 over 5. That's why the answer here is A. And so now last, getting into our exponents. So now with the first one, notice how here we're just looking for which expression? Well, you have a negative exponent. So with a negative exponent, what did that mean? We need that fraction answer, right? Because we need to reciprocate the base. So B is now going to become 1 over B, then to the 2 over D power. So that means I mark off C and D. So now keep in mind that this is B to the second power inside of our D radical. That's why the answer here is A. So now question 17. I see that we're multiplying in our numerator and denominator. So can we add our exponents? No, because the bases are different. But we're dividing and the bases are the same. So that means, right, when we're dividing from top to bottom, make sure now to subtract the exponent. So here we go. So for our base of 3, well, what is the exponent up top with this 3 here by itself? 1. So remember, it's understood to have that exponent of 1. So 1 minus 8/3. So this means here we've got 3 to the negative 5/3. So this is 1 minus 8/3, you get negative 5/3. So now let's go to our base of 7. So again, 7 top to bottom. So 2 minus, what is our exponent? Negative 1/4. So now notice we've got the 2 negatives going to make a positive. So 2 minus a negative 1/4, or 2 plus 1/4, is now going to give you 5/4. No, sorry, not 5/4, my fault. This is going to give you 9/4. Was this our final answer? Well, no, because we have a negative exponent. So again, that means we're going to have to get that fraction answer here to reciprocate. So what goes in the bottom, the base 3 or base 7 or both? Just base 3, because only 3 has the negative exponent. Leave 7 in the numerator. That's why the answer here is B. So then question 18, what's the value of y? So we're just trying to get the new exponent here after simplifying. Now keep in mind up top, that says the square root. So remember, it's understood to have an index of 2. So if I want to rewrite that, that is f to the, not 5/1, right, but 5/2. Then here we have a power to a power, parentheses, so multiply. So this is f to the 9 times 1/2, right? Power to a power, 9/2. Now we're dividing, bases are the same, so what do we do top to bottom? Subtract. So this is 5/2 minus 9/2, which gives you a new exponent of -2. Then our last two. So here we go. Same thing. Notice how we're multiplying. So can we add the exponents? No, because the bases are different. However, when dividing, we do have bases that are the same, but this one you have to be careful. So let's start with our x here, right? So again, top to bottom, we're going to subtract. So for x, we have 3/2 minus what exponent? -1/2, because the bases must be the same. So even though it got switched, you can't just go straight top to bottom, right? Bases have to be the same. So 3/2 minus -1/2. Notice again, you're going to get the two negatives making a positive. So this is x to the second power. So then for y, again, starting up top, right? So -2/3 minus 1/3, which gives you y to the -2/3 minus 1/3 is -1. So is this our final answer? No, because we have a negative exponent, which means we're going to have to reciprocate one of the bases. So which one is going to go in the denominator? X, y, or both? Just the y, and x squared. Remember, right, it's understood to have an exponent of 1 here, so we don't have to have that 1 here, but it's okay if you have that. But remember, it's understood. So now 20. Notice here, we need to rewrite before we can start simplifying. So here, x is now x to the 4/5 power times y to the -2 times, then technically x here has an exponent of 1. So I'll go ahead and put that 1 here. Now we're multiplying. So do we have bases that are the same where we can add the exponents? Yes, we have two bases of x here. So we can add these two exponents, 4/5 plus 1, which gives you 9/5 times y to the -2. Now, can we add these two exponents? No, because the bases are different. However, is this our final answer? No, because we have a negative exponent, which means we're going to have to reciprocate. What's going to go in the denominator? X, Y, or both? Just Y, because the base Y is what has the negative exponent. And X to the 9/5 stays up top.